Structures of cycloalkanes and their stability. For comparing stability of cycloalkanes, we have to check out what are the angle strain values. For the comparison of strain values, there was a formula derived which is D equals to half of 109.5 minus twice of n minus 2 by n into 90. So, this formula could be used for comparison of the angle strain that is observed when an open chain compound converts into a cyclic compound. So, what are the angle strain values and which one has more strain and which one has a lesser strain value. So, let us check out. See, the hybridization of carbon is sp3. Hybridization of carbon here is for each carbon sp3, this is sp3, this is sp3. So, each carbon is sp3. Here also you have sp3 carbon, sp3 carbon, sp3 carbon and sp3 carbon. So, similarly each alkane has all carbons sp3. For sp3 carbon, the expected bond angle is 109.5 degrees, right. So, expected bond angle is 109.5 degrees, but when formation of a ring occurs, there is definite strain in the molecule. So, for that strain we have this formula. Now, from this formula we have calculated values and we have put up these values over here. So, in cyclopropane the angle strain is 22.44 degrees, 9.4 degrees in cyclobutane, and in cyclopentane you have 0.44. In cyclohexane, cycloheptane, cyclooctane, it is in reverse order, that is angle strain is there but in opposite order, but in cyclopentane the angle strain is minimum. So, according to angle strain theory, most stable the cycloalkane which was found more stable was cyclopentane, but later according to combustion theory we concluded that most stable cycloalkane is cyclohexane. So, the stability order as of now what you must know is from angle strain this information you must know that from angle strain theory we came to a conclusion that cyclopentane was most stable, but I am saying but in reality or through evidence, see this was a theoretical concept, but through evidence we came to a conclusion that cyclohexane is more stable, that was derived from experimental values. We took these molecules to lab and we performed experiment and calculated enthalpy of combustion. That means heat released per mole combustion of these molecules, and we came to a conclusion that per CH2 molecule or I should say per mole of CH2 the energy release was found to be minimum in case of cyclohexane. So, from combustion theory we came to a conclusion that most stable cycloalkane is cyclohexane, not cyclopentane. So, stability order is cyclopropane is less stable than cyclobutane, cyclopentane is more stable than cyclobutane, and then cyclohexane is most stable, and this is more stable than cycloheptane as well. So, most stable cycloalkane is cyclohexane, most stable is cyclohexane. Alright, you have to remember that this is experimentally derived from theoretical values. From angle strain we figured out that cyclopentane is stable, but in reality through experiments we figured out that cyclohexane is most stable, because of which we have observed in all natural molecules there are more number of 6 member rings than 5 or 7 member rings. That came to us as another evidence that helped us conclude that cyclohexane is the most stable ring when comes to cycloalkanes. So, this is it for now. Thank you.